Hi everyone, welcome to my channel. We are going to solve exponential equations today by using logarithms. Now, we also solved exponential equations before but without using logarithm. So what is the difference? How to know when to use log and when not to? Let me show you an example. For questions like this, 2 to the power of x equals to 8, you don't need to use logarithms because it's possible to change 8 and write it in terms of 2. For example, 8 equals to 2 to the power of 3. So whenever you have the same base, you can actually cancel out the base because the powers, they equal to each other. So we can say from this question that x equals to 3. But what about questions like this? 2 to the power of x minus 10. I don't know 2 to the power of what will give me 10. So for questions like this, we use logarithm to solve exponential equations. Now in this video, I'm going to show you 6 types of questions that you can possibly have in the exam on exponential equations. So let's start. Okay, so this is my first question. 2 to the power of x equals to 10. How to solve it? Take logarithms both sides. This side I will have log 2 to the power of x equals to log of 10. Now this power, it moves to the front according to the rule of log. So it will give me x log of 2 equals to log of 10. If I want to find the x, you need to divide both sides by log of 2. Log of 2, this side it gets cancelled out and we just have x equals to log of 10 over log of 2. Now when you don't write the base, it means the base is 10. So you can just type log of 10 in the calculator divided by log of 2. This should be equal to 3.32. That's how you can solve questions like these. Okay, let's move to number 2. Similar type, but now for this question we have powers both sides. So what to do? I'm going to start with by taking log both sides. This side I will have log of 7 to the power of 1 minus x equals to log of 4 to the power of 3x plus 1. So according to the rule of the rule of logs, we can move it to the front. This side I will have 1 minus x log of 7 equals to 3x plus 1 log of 4. Now I'm going to move all the logs to one side and all the numbers to other side. This side I will have log of 7. So log of 7, I will move log of 4 to this side divided by log of 4 equals to, I have 3x plus 1 on this side divided by, I will move it to that side so it will be there. 1 minus x. So log of 7 over log of 4, you can actually find this value in the calculator and then cross multiply. So log of 7 over log of 4 will give us something around 1.40. That equals to 3x plus 1 over 1 minus x. Now I'm going to cross multiply. So I'm going to multiply 3x plus 1 with 1, that's just 3x plus 1, equals to 1.40 times 1 minus x. This will give me, I will write it this side. This side I will have 3x plus 1, that side I will have 1.40 minus 1.40x. Okay, so now that I have it, I'm going to move all the variables to one side and all the numbers to the other side. So this side I will have 3x plus 1.40x equals to 1.40 minus 1. 1.40 minus 1 will give us 0.40, right? Yeah, 0.40. And this side I will have 4.40x. If you want to find the value of x, you need to divide both sides by 4.40. This will give us 0.4 divided by 4.40. That's equal to 0.091. That's your answer for number 2. Let's move to question number 3. 3 is e to the power of 7 plus 2x minus 3 equals to 0. So before I take log both sides, I will move the number to the other side. This will have, as a result, I will have e to the power of 7 plus 2x equals to 3. Now, I'm not going to add log both sides. I'm going to add ln because the base of ln is e, and you can easily cancel out this e by taking L of n. I mean ln. So ln, you don't need to write the base. When you write base, it just means that the base is e. So I will have ln of e to the power of 7 plus 2x equals to ln of 3. The power will go to the front. I will have 7 plus 2x times ln of e. Now ln of e is just 1 because the base of this is also 1, and whenever we have the same number and the same base, you can cancel it out and just write 1 equals to ln of 3. I don't know what ln of 3 is, but you can find it in the calculator. So now this side, I want to make x the side because x the subject, because you want to solve for x. This will give us 2x equals to ln of 3 minus 7. I moved the 7 to the other side, it's positive. So when you move it to the other side, it becomes negative. Then I'm going to divide both sides by log of just 2. This side, you can cancel out the 2's. So I just have ln of x equals to ln 3 minus 7 over 2. You can put it in the calculator and you will get something around negative 2.95. So this is my answer for number 3. Okay, let's move to number 4. Okay, this is a different type. We have 2 times, this is not x by the way, 2 times 3 to the power of x equals to 5 times 2 to the power of x. So I'm going to take log both sides first. This side I will have log of 2 times 3 to the power of x. This side I will have log of 5 times 2 to the power of x. Now we know, according to the rule of log, if you have log of a times b, this just equals to log of a plus log of b. So I can break this down and write log of 2 plus log of 3 to the power of x equals to log of 5 plus log of 2 to the power of x. Then I'm going to move all of these things, like the numbers with the variables, to one side and all the normal logs to the other side. This side I will have log of 3 to the power of x minus log of 2 to the power of x equals to log of 5 minus log of 2 minus log of 2. Yes, okay. So this side, you can actually move this x to the front. So I will have x of log 3 minus x of log 2 equals to log of 5 minus log of 2. This side you can actually take out the x because x is common in both of these terms. So I'm going to use a bracket. X times log of 3 minus log of 2 equals to log of 5 minus log of 2. Now if you want to find the x, you just need to move this whole thing to the other side. So I will have x equals to log of 5 minus log of 2. Oh, that's long. Over log of 3 minus log of 2. Just type it in the calculator and you will get your answer, which is something around 2.26. So that's my answer for number 4. Okay, let me draw a box around it. Okay, let's move to number 5. Number 5 is a different type of question. So we have e to the power of 2x, then we have e to the power of x, and we have one number. So for questions like this, you always need to separate the e to the power of x. So if I do that, I will have e to the power of x, and then I will have a 2 outside, minus 5, then e to the power of x, plus 6 equals to 0. So if you look at this equation, it is actually in the form of a quadratic equation. But it's kind of hard to solve with e to the power of x. Students get confused. So what you can do is you can substitute a letter instead of this thing. So you can write, let e to the power of x be only x. And then you can substitute this x back into this equation. you will have x to the power of 2, because there is a 2 outside, minus 5 times x plus 6 equals to 0. Now you can see that this is just a quadratic equation, so you can easily factorize this. You have to think of two numbers that will add to give you negative 5 but multiply to give positive 6. So the two numbers are negative 3 and negative 2. If you solve it, you will get two values of x. One is x equals to 3, the other one is x equals to 2. Now you have to remember that this is not the real answer. This x is not really x, it's actually e to the power of x. So I'm going to write e to the power of x equals to 3. And how to solve for this x? You can take ln both sides. This side you will have ln e to the power of x. This side you will just have ln of 3. Now you can move this x to the front. You will have x ln of e. We know that the base of ln is e, so you can actually cancel this out. So this equals to ln of 3 only. For this value, you need to do the same thing. E to the power of x equals to 2. I'm going to take ln both sides, ln of 2. X will go to the front. Ln of e gets cancelled out. This just gives us ln of 2. So you have two solutions for this question. One is x equals to ln of 2 and the other one is x equals to ln of 3. Okay, that's all for number 5. Let's move to the last question for the day. So we have 4 to the power of x plus 2 to the power of x plus 2 equals to 3. So this is kind of similar to number 5 because you can separate 2 to the power of x from this. So how can I do that? 4, you can actually change it and write it in terms of 2. So 4 equals to 2 to the power of 2x plus 2 to the power of x plus 2, x plus 2, and then you can move the 3 to this side, minus 3 equals to 0. Now, you have to separate this e to the power 2 to the power of x because you want to form a quadratic equation with it. How can you do that? 2 to the power of x, similar to the last question, 2 to the power of x, I will just write the 2 outside. But what about this? 2 to the power of x plus 2, this actually equals to 2 to the power of x times 2 to the power of 2 according to the rules of exponents that I already explained before. So 2 to the power of 2 is just 4, so you can write it's actually 4 times 2 to the power of x. I'm going to separate it because I'm going to assign another variable for it. So let 2 to the power of x be equal to x. So this side I will have x squared plus 4x minus 3 equals to 0. So you can see that this is a quadratic equation again, but it's kind of hard to factorize this because you can't find two numbers that will add up to give positive 3 but multiply to get negative 3. So when it's not possible to factorize, you can always use the quadratic formula. So x equals to, quadratic formula is x equals to negative b plus minus of b squared minus 4ac divided by 2 of a. Now what is this a, b and c? A quadratic formula is always written in this form: ax squared plus bx plus c equals to 0. So a is the number with x squared. We don't have anything, so I'm just going to write a equals to 1. b equals to positive 4 and c equals to negative 3. So I'm just going to substitute all these values back into this equation to solve for my x. This will give me x equals to negative 4 plus minus, in bracket I will have 4 squared minus 4 times a times negative 3 divided by 2 times 1, which is just 2. So if you simplify this thing first, 4 squared, remember you have a negative here and also over there, so negative and negative is actually positive. So it's actually 16 plus 12, that will give us 28. So x equals to negative 4 plus minus of square root 28 over 2. Now you can just put it in the calculator and get two values for x. But you can also simplify this equation. You can write 28 as 4 times 7 and 2 is just 2. So you can take out this 4. Square root of 4 is 2. So this side you will have negative 4 plus minus 2 root 7 over 2. So you can actually simplify, divide all the terms by 2. So you will just have negative 2 plus minus 7. This 2 and 2, negative 4 divided by 2 is negative 2, and positive 2 over 2 is just 1. So I'm just writing square root of 7. So now you have two answers for x. One is x equals to negative 2 plus square root of 7, and the other one is x equals to negative 2 negative square root of 7. It's not possible to have this value because it will be a negative number. So our only answer is going to be negative 2 plus 7. Okay, let me write it in the calculator. Negative 2 plus square root of 7 will give me 0.646. Okay, now remember, this is not really the x. This was actually 2 to the power of x equals to 0.646. How to solve it? You can take log both sides. Log of 2 to the power of x equals to log of 0.646. The power moves to the front. Then we will have x log of 2 equals to log of 0.646. So if you want to solve x, you need to divide both sides by log of 2. I'm going to cancel this out. So I will just have log of 6 point, that the whole thing, divided by log of 2. Okay, that will give you something around negative 0.631. Okay, so that will be all for today. If you like my videos, then don't forget to subscribe. See you next time. Thank you.